Suppose that the rabbit population in Conway is cyclical and can be modeled with a sinusoidal curve. Further, suppose that the high population density is 15 per acre and the low population is 5 per acre. The period of the cycle is every 8 years, and 2 years ago the population was 10 rabbits per acre and rising. Let number one, let t be the number of years from now, and let p be the rabbit population density. Express p as a sinusoidal function of t. First thing I want to do is make a good picture. Okay, so it says that the high is 15 and the low is 5. So let's, guess we can kind of do this to scale. So 15 at the top, and then 5 here, and then 10 is the middle. That'll be important to us. And then it says that 2 years ago, the rabbit population was 10 rabbits per acre and rising. So apparently, if you're over here at -2, then you are right there in the middle, and you are on your way up. So I don't know exactly where it's going to be just yet. So let's look at this last piece of the puzzle. So here we see that the period is 8 years. And a while back, I used to talk about how I always take the period and divide by 4 to figure out exactly where the different pieces are, like the 5 important points. You know, they're each spaced out by whatever this number is. So we take 8 and divide it by 4, we get 2. So actually every 2 years is a quarter of the period. Which is no coincidence. That means that the next important point on this graph is 2 years after this point right here, and 2 years after this lands me right at 0. So the next important point, let's see, it said it was 10 rabbits per acre and rising, so this must get up to the top right there on the y-axis. So it feels like the next point is right there, and then 2 years after that, we're back in the middle, and then 2 years after that, we're at the bottom. And then 2 years after that, we are, where are we then? Back to the middle. And let's go ahead and do one more 2 years after that back at the top. And we'll go ahead and draw our curve. And now we'll come up with an equation. We wanted a sinusoidal function. So let's find the different pieces. Amplitude, how far from the middle up to the top is 5. The midline is at y equals the middle, which is 10, just averaging 15 and 5. Next thing we need is the, what do we need here? The period we've already found. So let's just write it here. And that means that we can find the b value, which is always 2 pi divided by the period, or just pi over 4. And then you can think of a horizontal shift, or if you're clever and or lazy, you'll try to avoid a horizontal shift. So I am at least one of those two things. So I'm going to take a look at where this function starts, like on the y-axis. It starts at the top, heading down. To me, that's naturally a cosine function. If you prefer, you can start this guy here, which is kind of where the first piece of information was given to you. And you can say, oh, it's in the middle, and it's going up. And you can think of it as a sine function. But then you'll have to make sure that you move it to the left, because normally sine functions would start right there at the origin, but this one is starting out here to the left. So I'm going to be clever and or lazy and think of it as a cosine, but there are many different correct answers to this one. But I'll just write this one. So what do we have here? Instead of y equals, they're saying use p. So I think of that as a cosine. Amplitude goes first. Okay, and then we put the 2 pi over the b, or 2 pi over the period, so that's pi over 4. They say use the letter t instead of x. There is no horizontal shift, so we don't need to put a minus anything there. And then plus the midline, 10. So there's one perfectly good answer. I think that's going to be the easiest thing to use, but we'll go ahead and write an alternative. You could also think of this as being a cosine, as a sine. Everything else is the same, except you're going to have the complication of a horizontal shift. So normally the sine graph would start here and then go up. We need to move it 2 places to the left. We accomplish that by putting a +2 in here. So either one of those is fine, and you might type one or both of those curves into your graphing calculator and make sure that it gives you exactly what you expect it to. Okay, number 2, what should the rabbit population density be now or in 2 years? Does your function give this result? If not, revise it as necessary. Okay, so I'm just going to highlight our 2 the one in yellow or second one in blue. Okay, so right now the rabbit population density, so right now means it times 0, so that's right here. So it should be 15 right now. So now this t equals 0, and it should be population is at 15. And then 2 years from now, so in 2 years, t is positive 2. And if we look at the graph, positive 2 is here, and it should be at 10 at that point. So we should get p equals 10. And this would be a good opportunity to really make sure that the function that we picked is correct, or does what we think it's supposed to do. So let's go into y equals. And I'll go ahead and I'm going to use the more complicated one just because it's more complicated and it's going to be harder to solve the rest of the problem. Not terribly harder, but a little bit harder. And just in case you end up choosing the more complicated one, because you're not as lazy as me, then I want you to be able to handle it. So we'll use the more complicated one, plus 10. And let's go ahead and do what I had said. We'll look at the window here. So how about we go -2 to 8, just so it looks exactly like we drew up here. And then the bottom at 0 and the top at 15. And how about we go by 2s? Those are the quarter periods that we saw. Window range. Let's try that again. Okay, what's going on here? Oh, this one should have been a 1, and then a 0, and then a 15. Okay, I think that that's fine, and then we'll go by 2s. Okay, 2 years ago, right now, 2 years into the future, back in the middle. So this is looking quite good to me. In order to figure out if we got it right here at 0 and 2, we just have to hit, what do we have to hit? So you can do second calc and then value, and then you can just plug in 0, enter, 15, 2, enter, 10. Notice it's even going to put the cursor for you right there at 210, so that's kind of a nice feature. Okay, so the second equation looks good to us. Just to make sure I don't go too far in this video with an equation that's completely wrong. For my benefit, I'm going to type in this one, 5 cosine pi over 4, and then plus 10. Now, if I got it right, then I won't see anything, so I need to change this. I'll hit enter once, and it changes it to thick. So now it should trace perfectly over the previous one that we had, and that's looking pretty good. Okay, so I'm going to turn that guy off so we don't have both drawn at the same time. Okay, number 3, what will the rabbit population density 7 years from now be? Okay, so now it's not some nice number like 10 or 15, so we have to do a little bit of work here. So this problem is really asking you to find p of 7, so I'll use the blue function, 5 sine of pi over 4 times 7 plus 2 plus 10. Okay, I'm going to use my calculator ultimately, but before I do, I'm going to go as far as I can without, because it's quite a complicated thing to just type in as it sits, and I think if you can do some simple stuff in your head, you can eliminate some of the complicated typing. So 7 plus 2 is 9. I would never type 7 plus 2 into my calculator. And then this one I think we can type in, so let's type that. There. Okay, so we got 5 sine, make sure you're in the right mode. Pi divide by 4 times 9 plus 10. Okay, we get that number. Is that reasonable? Okay, 7 years in is here. It's past the midline, so it better be something between 10 and 15, and maybe a little bit closer to the 10, maybe? Let's see what it says. 13. Oh, 13.5. It's actually a little bit closer to the 15. Okay, so that answer seems reasonable. If you really want to just use the technology, then go back to the graph and just do the second calc, number 1, and then type in 7, and we should get the same number that we just got, 13.5355. If you really want to see it's the same number, type in, actually, nope, don't type anything. So there's the answer right there, 13.54. 13.54 years from right now. 4, without using a calculator-generated graph, determine the next 3 times from now when the rabbit population density will be 7 per acre. Hint, use arcsine or arccosine. Just a reminder, those are equivalent to inverse sine, inverse cosine, which are the two that I generally write. Okay, so we need the graph to, or we need the rabbit population to be 7 per acre. So if we go back to this blue highlighted equation, 7, does 7 go in for the P or for the T? Population is supposed to be 7 per acre. Oh, okay, that's a P. So we're just going to write that same equation up above, but instead of the P, we put 7. I apologize for choosing the more complicated one, but if you can follow the explanation here for using the more complicated equation, then using the simpler equation that was up above will be even easier. Okay, trying to solve this trig equation. We have spent 2 full classes solving trig equations so that we could get to this moment here and solve trig equations in context. Okay, first step is to isolate the trig equation. So we're trying to get this thing right here by itself, and we will do that by subtracting 10 and then dividing by 5. So subtract 10, divide by 5, and now the trig function is isolated. And now we'll do inverse sine of both sides. I'm going to swap the sides of the equation here. Negative 3/5, that's good. Okay, so that's fine. And then, yeah, that's fine. And then we'll just go ahead and use the calculator to help us here. So we need inverse sine of negative 3/5. Okay, so we get that number. So pi over 4 times t plus 2 is approximately this thing. Okay, and it could be, quite frankly, that we don't have to do anything else here except solve for t. So I don't really know what the best approach is at this moment. Normally, if we were looking for every solution, we would take this one fundamental solution. We would then use the unit circle to find the other fundamental solution. Then we'd tack on the 2 pi k's, and then we would actually do the algebra to solve for t. Now, we don't need to find every solution. We just need to find the first one. What are we looking for? Oh, it's the next 3 times. Oh, well, heck, let's just go through the process then. I thought we were only looking for the next single time, and it's a lot of work just to find the one single time. But for 3 times, well, that's a bargain. So let's go ahead and find the other fundamental solution. Okay, so we'll use our friend the unit circle. Negative 0.6 is in the 4th quadrant. This was a sine that I chose. You might have gone the cosine route, in which case you'll diverge a little bit from what I'm doing here. But sine is related to the y, so the same y is over here. And we'll draw this guy and know that this is a, so that was a negative 0.6, so this is 0.6 in here, which means that the standard version of the angle is pi plus 0.6. So red pi plus 0.6, which is, let's see, so what are we doing here? Pi plus the 0.6, so 3.785. Oops. Okay, so 3.785. Super. Now we'll stick on our 2 pi k's now that we've got our fundamental solutions. And now there's still work to do. We got to solve for t. Here it's 2 steps to solve for t. We'll get rid of the pi over 4, and then we'll get rid of the plus 2. If you had gone the cosine route, it would only be 1 step. But like I said, I wanted to do the harder version just in case you don't happen to see the easier version when you do problems like this on your own. So what are we doing here? We need way more space than I've allotted. So let's multiply both sides by, 4 over pi. So we go 4 over pi times the whole big mess. Normally I don't write this, but this one is kind of tricky, so we're going to write the details. Plus 2 pi k there. What happened? Holy cow. That's what happened as I used the big eraser. Maybe this one. we're just going to stop. Okay, so we'll leave that as it is. And then subtract 2 from both sides. So I will be a little bit lazy here, and I will subtract. Okay, this is getting annoying. Okay, I'm not going to be lazy because the technology is preventing me from being lazy. So let's go ahead and subtract 2 from both sides. And again, I said I don't normally write all this out, but this one is kind of complicated, so we'll put it out and subtract 2. So there's the answer. Let's go ahead and do the calculations here. So t is equal to, so we're going to multiply the 4 over pi times that negative 0.6. And in fact, we're going to have to multiply the 4 over pi times this 3.78 as well. So we may as well do that now. So multiply by 4 divided by pi. And then I'll type in the other one, which is the one we're working on, negative 0.6435 times 4 over pi. Okay, so that's the first one that we need, negative 0.8193. And then plus, and then when you distribute it here, this 4 over pi comes in. We just did that, but it also comes in here. And when it comes in the second one, the pi's cancel, and 4 times 2 is 8. 8, okay. And 8 is a really comforting number to see there because that's exactly the period of this function. This thing repeats every 8 years. And then we subtract off the 2. So t is equal to negative 2.8193 plus 8k. Super. At this moment, that's done. That's all the solutions of that first family. And it's the same process for the other family. I won't write all the details this time, but this guy right here becomes t equals, so what are we doing? We need to do the 4 over pi times the 3.78 plus the 2 pi k, and then subtract the 2 on the outside, and this is equal to, and now we can use the number we have on the calculator. So we've already done that calculation. I think it's 4.8 if I've got it right. So 4.8 and then subtract the 2 gives me 2.8. So what do we have here? 2.8193 plus, and then it's the same 8k that we had before. Okay, so we've got our, we have the same number. Is that reasonable to have the same number? Okay, I do think it's reasonable. I was a little bit surprised to see the negative 2.819 and then exactly the same thing but positive. But then I took a quick peek at our graph up here, and we'll go ahead and draw in. We were looking for places where the population was at 7, a density of 7. So if I go ahead and draw in a horizontal line at 7, maybe this one up here, p equals 7, then we will find many points of intersection, but in particular, we've got this one right here, which 2.819, that seems reasonable. And then there's another one over here, which is symmetric over the y-axis. So that seems perfectly reasonable as well as a negative 2.819. So I think those are both good. And then we can just use our formulas here to get the rest of the answers. So next 3 times when the population was, okay, so I'm not using the space for this problem right now, but we're just doing the previous one still. So all we have to do is let's write out our first few numbers, and maybe a chart is appropriate here. K, and then just like before, I think we use T1 and T2. So how about we say that this guy right here is T1, and this one over here is T2. And so, for example, if you pick k equals 0 and plug in, then this term is nothing, so you just get the negative 2.8. And this term is nothing, so you get positive 2.8. So let's fill those in here. Actually, this one was the negative. This one is positive 2.819. Great. And then if we plug in k equals 1, then essentially that just means we're adding 8 to each of these numbers right here. So this becomes a 6.819, a 10.819. And you can go further. Okay, I paused there because this 6.819 is not right. And the reason it's not right is because adding 8 to that number is not as simple as just adding 8 to the negative 2. Let's just go ahead and say this is not going to be in one of my greatest YouTube hits. So let's actually try to find this on the calculator. So we'll go ahead and do negative 2.819 and then add 8. And shock, it's not just 6.819. Okay, so about 5.181. Okay, and I think that those times right there, not counting the negative, are the first 3 times from now when the depth, or sorry, when the population density will be at 7. You know, we got that negative answer, the negative 2.8. That just means 2.8 years before now, and that's a perfectly good answer. It's just this problem said the first 3 times from now. Okay, so we've done that. And if you wanted to check your answer, come in here and you could type in, so I already got my formula, I've got 2 formulas, and then I typed in y equals 7 so that it would graph that horizontal line, and then all I'm looking for are these first 3 intersection points. And so second calc, 5, first curve, enter, second curve, enter. For example, if I wanted this one out here, I guess I would say this is some number. Well, apparently the answer is 10, so, or 10.8. So if I just guess 10, then it should put the cursor right there and tell me that 10.819. And you can find the other answers by going back into second calc and just going through that process again. Okay, so I have absolutely no space for this 12 per acre, but the good news is that I think we can just kind of take the work that we did and just tweak it slightly. So instead of 7, this should have been a 12. So when I subtract, well, I guess I'll just write that equation and start from there. Okay, so down here, oops. So down here, this is now problem number 5. We'll make a note. Okay, so instead of having 7 equals, we now have 12 equals. And then all the stuff that we wrote before. Okay, let's make sure that's exactly what we wrote before. Okay, that seems good. And then same thing, isolate the trig function. So that means subtracting the 10 and then dividing by the 5. So subtract 10, we get 2. Divide by 5, we get 2/5 equals sine of a bunch of stuff. Not going to copy that. Then inverse sine of both sides. So we get pi over 4 times t plus 2, just swapping the left and right hand side, is the inverse sine of 2/5. We'll go ahead and make our 2 different, so we'll use the calculator for the first answer and then symmetry for the second. So what are we doing here? Inverse sine of 2/5. Okay, I won't draw the unit circle, but that's in the first quadrant, which means the other answer is in the second quadrant, which means it's pi minus that number. So here are our 2 fundamental answers. Okay, and then we'll stick on our plus 2 pi k's at this moment. And then we have to do the algebra where we solve for t. So that means that we're going to, just like before, multiply by 4 over pi and then subtract 2. So let's try to do that, just kind of taking some shortcuts here on the calculator. So what are we doing here? So we're going to multiply by 4 over pi. And we'll get something. And then we're going to subtract the 2. And we get that. And so that right there is what the second set of solutions turns out to be. T equals 1.476 plus And then the 2 pi k becomes 8k, just like it did up above. When you multiply by 4 over pi, it becomes 8k. And then we play the same game up here. So we use the calculator. I'll just go back to the beginning. So we had inverse sine of, what was it, 2/5. And then we had to multiply by, 4 over pi? And then we had to subtract 2. So let's try this again. Subtract 2. Okay, so hopefully that's okay. Negative 1.476. Not surprised this time. I was surprised the first time, but now that I've thought about the symmetry of the original graph, that seems reasonable. And then plus your 8k. And so then we can make our chart real quick. K, and we'll go ahead and call the first one T1 and the second one T2. And if we plug in 0 and 1, I think that'll be enough. So if we plug in 0 in for both, we'll just get negative 1.476 and positive 1.476. And then we plug in 1 for both, which means adding 8 to each of these numbers. So this one I can do, add 8 to that, add 8 to the other guy. All right, let's do this without the calculator. So we're adding 8, so that becomes like 6 and change, right? And the change is 524. Okay, let's try and see if that's right. So what are we doing? That number plus 8. Okay, good enough. So those are our 3 answers. The next 3 times from now, meaning the next 3 positive answers. And again, you can use the calculator to intersect and make sure that the calculator agrees with all the numbers in the table.